One of the required practicals you've got to be able to know about involves finding the resistance of resistors in series and parallel and investigating it. So that's what you're going to do today. Now, this is a resistor. It's just a really tiny component, and this is what most resistors look like. However, the resistors you're going to use look slightly different. I've got one here in a component holder. These are ceramic resistors, and the reason why we're using these is because these only like a tiny amount of current going through, whereas these can withstand a little bit more, and we want enough current to be able to read it on our ammeter. So you have learned the key equation for resistance, I hope, and that is that resistance is equal to potential difference divided by current. Okay, and if you don't know that key equation, if you haven't got it written down, write it down now because you are going to use that. So R is resistance, we measure that in ohms. V is potential difference, we measure that in volts. I is current, and we measure that in amps. So to be able to find the resistance, we need to measure potential difference. Great, we've got our voltmeter. And we need to measure current. Great, we've got our ammeter. Okay, so what we're going to use, I'm going to use a power supply today. I'm going to use one of the power packs. You might be using battery packs, absolutely fine. It doesn't matter which one you use. Now you only need a very small potential difference. So I've set the power pack onto 2 volts. If you are using the battery packs, only use one of the cells, so 1.5 volts. So I'm going to plug in. I want to use direct current because my ammeter and my voltmeter, they only work with direct current. So I've plugged into those 2 holes there. Those are the ones we use if we're using alternating current, which you won't use in GCSE apart from triple science when we're doing about transformers. Okay, so I'm going to find the resistance of this resistor first of all, resistor A. So I plug in to the ammeter. I plug in from the ammeter to the resistor. And I'm going to plug in from the resistor to the power pack again. Right, so I've plugged that in. You can see it's just a circuit. Power pack goes to ammeter, ammeter goes to resistor, resistor goes to power pack. I'll just turn it on and check I get a reading on the ammeter. Yes, I do. I'll turn that off because I need to put the voltmeter in. Now remember, you've got to put the whole circuit like that with the ammeter in series before you put the voltmeter in. So I'm going to just plug the voltmeter into the back of these 2 bits here. Right, I've plugged in the voltmeter at the front here, and so the circuit I've got is that circuit there. Okay, so what we're going to do is we're going to take a reading for potential difference, we're going to take a reading for current, and then we'll work out the resistance of that resistor. So turning the circuit on, I'm not going to leave it on for very long. I've got a current of 0.15 amps, and I've got a potential difference of 1.53 amps. Okay, so that's my current, that's my potential difference. What I'm going to do now is I'm going to use our key equation here to find the resistance. So resistance is equal to 1.53 divided by 0.15. Put that into the calculator. And it comes out to be 10.2 ohms. Okay, so the resistance of that, 10.2 ohms. Okay, so that was resistor A that I used. I'm just going to repeat that for resistor B, and all I'm going to do to do that is I'm going to switch the circuit off, unplug those 2 connectors and swap it over to this and get another reading. Repeating the equation, the experiment with resistor B, I've got these results for resistor B. So resistor B is 10 ohms, and if you remember, resistor A was 10.2 ohms. Now what you've got to do is investigate, well, what happens when you put those in series and parallel. You've just got to be a little bit careful in series. When you put them in series, what you'll need to do is have them in series, make sure that you've got your ammeter in that circuit. Your voltmeter will need to be connected over both of those. Okay, so I'll just set it up quickly so I can show you how it needs to be set up. Okay, now this is the circuit setup. You'll see what I've got now is the power pack going to the ammeter, going to one of the resistors, to the next resistor, back to the power pack. And I'll just turn that on and check I get a reading on the ammeter. Yes, I do. It's a lot lower now because it's got more resistance. Then the last thing I need to do is connect up my voltmeter. Now I'm going to connect it from where the electricity goes into this one to where the electricity goes out of that one. So just be careful that when you put your voltmeter on, your voltmeter goes over both of them, okay? And that should give you a reading for potential difference and for current. And you can see what happens when you've got two resistors in series. You're then going to repeat that for two resistors in parallel. Good luck.